Yo, good morning, good morning. Let's go. So, I'm not entirely sure how I want to continue today. But we're going to continue with the visuals for the creatures or the randomization of them. But at the end of yesterday's stream, we started looking into Poisson sampling. Let me see if I can bring it up again. Just to get a set of random points on a shape, rectangle in that case. And we don't want these points to be too close together, so we get overlapping eyes. And, oh yeah, of course. And also started thinking about, like, maybe we should just go with a mesh solution instead. So get a random point on a mesh, pretty much. But I don't know. We'll see. So the solution we get here, it's for a rectangle. It can be a little bit generalized or generalized to work on a 3D mesh surface as well. Weighted by triangle area. That's probably... Yeah, I think something like this is probably what I want to go with. And then I'm thinking... And then we can probably... then we can probably generate our own... Or we can create, much like sometimes, in rare cases, you create like a collision mesh. Maybe we can create a spawn mesh. So for some of these, instead of defining the spawn area by X number of shapes, we define it by a simplified mesh. In a case like this, where the model or the creature mesh is simple enough, we might just use that one, honestly. I don't know, let's see. I wonder if... I think that is probably the best approach. And then I guess... let's try it. Probably want to alter it a tiny bit. So that... we don't want... Sometimes we don't want it to overlap on the faces, and sometimes we do. We'll see. Yo, what's up, Cypher? Long time no see. Hope you have had... Fuck, have we seen each other Was last time before summer. Hope you have had a nice time since we last saw each other, at least. Okay, let's see what we have. One sec. Apuk, as I see today, is going to be a freestyle stream. Aren't all the streams freestyle streams? I guess. Cypher, indeed, been a while. Yeah, just busy. Hope you're well, man. Yeah, I'm good. Hope you're good as well. I'm just keep on grinding, you know. Hope it has been the enjoyable type of busy for you, at least, Cypher. Okay, randomly sample triangles weighted by area. Generate random barycentric coordinates on those triangles to get uniformly distributed points. Okay. Keep each accepted point only if it at least radius units away from all others. Okay. Like, we're talking about... We're not even gonna have... I think our maximum is gonna be around 100, probably. Get the triangles, get the vertices, get the normals. Wait, so we loop through... I wonder, this is... it feels a little bit too much. I guess we would get pretty nice randomly distributed visual features for our creatures, but I don't know. Cypher, we embracing our new overloads now then? Hell yeah, we are. Yo, what's up, Woot Dragon? We meet again indeed. How's it going? It's going, you know, it's just, we just started, so it's this slow startup period, but I think it's going pretty good so far. Drinking my first cup of coffee for today as well. The projection is positive, at least. How about you? Are we gonna... I don't know. I mean, it's pretty cool. So assume that we're creating new creatures and we define and we want them to have X number of visual property Y distributed on, and then we can specify the surface by a mesh. Isn't that pretty handy? Ooh, Dragon, very nice. Got my glass of cola with ice. That sounds hella good as well. Fuck, I wonder if we're just gonna skip Poisson. I think we're gonna skip the Poisson part. I think we're just gonna get a random point on a mesh. Random point on a mesh. And then we spawn the object and we check. Fuck. Yeah, we're probably gonna. Let's see, mesh Unity. I wonder how much time we want to put in, like, how much time do we want to allow for this generative process at every creature's instantiation? If we can thread it, multi-thread it, it's okay. Then we can probably give it up to 1 minute. I don't give a fuck. But if we can't, I guess we're gonna have to. Like, if we can't, we just want to give it like 10 milliseconds pretty much, and that's way too small. Wood Dragon multi-thread bad? Elaborate, please. What the fuck, man? It's too early. It's too early. I'll say I wonder if we have a check box. It would be beautiful if we had like overlap mesh. Wood Dragon will depends on how many threads you use. I guess that's true. But I guess we could take the mesh bounds. Uh, what the fuck? Because I mean, getting like randomly spawning these properties on the mesh. I think that's pretty straightforward. I don't think we need the Poisson for that, but I'm thinking of doing the I don't know what the correct terminology for that one was, but like we spawn it, we check if it's colliding with anything. If it's not, we keep it. And the main reason I want to do it like that is because if we look at a Poisson distribution, we don't have access to the size, the radius of the object from the get-go. And it's not always going to be straightforward to get it either. So maybe we can just do it with bounds, actually. So I wonder if we want to do it like this. Let's see. Let's save this one. And then we do... I wonder... Okay. If we want to do it like this, get random point on mesh with constraints. So when I say with constraints, we might want to make it so that we constrain we make it so that we constrain which normal. So we only want to spawn properties. We want to spawn it on this mesh, but only where the mesh triangles has a normal of X, for instance. So we can decide to only spawn it on this one or only on this one and so on. But yeah. Spawn object. Check collision. Not destroy object, but start over. Continue. So I wonder if we want to do something like this, but one sec. Phone call. Okay, back. Sorry about that. So I wonder if we want to do something like this. A bit more of a brute force solution, I guess. Because we never know how much space we actually need for each point. So I think like if we had all the computational power in the world and all the time in the world, I would probably go with a solution like this. Feels simple and straightforward. And then we can simplify it as well when we talk about, when we check this collision here. We want to make sure that, or it depends on like how specific do we want this collision to be. Is it okay if we just check the bounds of the mesh, or something else? And then I wonder, it's going to be quite costly if we go to this one. So for every visual property we spawn and generate, we want to check if they collide. I think there's really no way around the fact that this is going to be costly. To do. Let's see what we can do. Yeah, let's just go with something simple like this, and then we do a bounds comparison, and then we roll with it. See how it looks. See if we can add some constraints to this. Like triangle normal and stuff like that. Yes, it would be nice to have a solution where we don't recalculate this every time. Do okay, I get it. I mean, we can probably store this. Uh, okay, we're gonna do this distribution. Let's just rename this one. Yeah, that's even a better name, honestly. Rename. Uh, let's see, random distribution. Okay, get vertices, get triangles. Magnitude. Yeah, I want to store this one. I want to store cumulative areas. I wonder if... Do we have a plane here? A plane shape. Let's see. Let's stop this one. We don't have any triangle shapes here. No. Okay, I think we're gonna do that. So we're gonna do... Let's make a triangle. We care about origin. Do we need it anywhere? Get random point. Get bound points. Because I want to store these. I want to keep the area, but I also want the normal because I want to add some constraints later on normals. Yeah. We do it like this, maybe. And that's the normal. And what about the size? The size. On a plane, what do we do? Yeah, we have it like this. Size, what the hell? What the fuck is the size of a triangle? Can we skip it? Maybe. We'll see if we need it or not. Get tangent. In fact, then we might just do it like this, actually. We're gonna do area as well. Size might be... I will see. But tangent, that's just b minus a. I guess we could do it like this, can't we? Um, But if we do... Hmm. Hmm. We get random point. Get random point in triangle. Oh yeah, it's just random point by barycentric coordinates. Yeah. Get bound points. Yo, what's up, Geralt? Good morning, good morning. Contains, contain. Okay, we still can't do it like this. Okay. Or am I missing something here? Okay, we're gonna do it like this. I want to call it normal direction or something like that. We have normal v dot normalized, but I also want to have area is equal to v dot magnitude times 0.5. Yes. Because then I want to use these shapes here instead. So cumulative areas. Oh, is that how they do it? Hmm. Huh. Get it, I get it, I get it. But what do I? Total area. It's 0. Plus area. Okay, yeah. Mm-hmm. And I get the try index. Yeah, the thing is, this is pretty straightforward and pretty nice, but it doesn't allow for the type of constraints I want to do. So if, and let's say that we want to spawn points on the mesh, but we only want to do it on triangles with a normal of, I don't know, 1, 0, 0, and within 10 degrees of that. Then we're gonna need to, like, we would need to sort we would need to remove stuff here. Like, we would want to sort, when we go through the mesh and take all of the triangles, we would like to sort, get rid of triangles that don't support. But we can get to that eventually. Mesh versus mesh triangles, cumulative areas. And then when we have these, we do triangles is equal to new area we have. Okay, would I like to... Here we just do yeah, let's try it. But also, yeah, we're gonna add some extra functionality. Like, let's bring up this one. Let's bring up GIMP so I can draw some cool stuff. So let's say that we have this triangle. So we randomize the triangle, we randomize a point on that triangle. Maybe we get this point. And then we try to spawn something this big on this point. And we don't want to allow this. So I want to send in some type of constraint that, okay, the thing we're going to spawn here has a radius of X. This we know before. Hey, what's up, Harukanen? Yeah, we're doing some very intricate stuff today. But if we only do radius, then we could move these points inwards before we randomize the point, so that we know that we are 100% sure that even though we get an edge point, we have enough space to spawn this object, right? That's one constraint we have to add. Like, I need to write all of this down. And like, even though we have that spawn, we also want to check so that it doesn't collide with anything else we have. Right, but let's try this one first. One thing though. Fucking hell. I actually have point. Maybe we should make this into shape as well. This one has a position and a normal. Game object and collider as well. I think we can use this one. Yeah, because when we return, let's see here. The random point, get random point on mesh, transform. Fuck, it would be nice to return point. Position is, yeah, we might wanna, fuck, do I? Yeah, probably. If so, we do that's our point. This is our normal. And transform.gameObject. This is our game object. And let's just do it like this. Return. Why? Oh yeah, of course. Otherwise, just this. Because now we actually have a point with a normal. And we're good to go, I reckon. Let's try this one. Before we continue, I'm wondering, point shape. Is point a shape? A point, get bounds, bound points, get random point. It would be nice. Fuck, I'm wondering, it would be nice to have these. Hell, yeah, I think we're actually, depends on how you define a point. I guess we could define a point with a radius as well. I mean, game object collider, world space position, yeah. Also, TwitchBot 4000. Very suspect name. I should have paid more attention when reading Euclid's Elements. I don't even know what Euclid's Elements are. So me too, I guess. Actually, I'm gonna add that as a to-do. Fucking hell. Make point, implement, shape. It's a famous book about geometry, Euclid's Element. A 13-book mathematical treatise written around 300 BC. It's a nice thing that Christmas is coming up because I know what I'm gonna wish for. Okay. Random distribution. Whatever. Okay, let's try this one real quick. We don't have any constraints here. No constraints whatsoever. I wonder if I would like what I would like to constrain eventually is I just want to add I just want to add triangles that has a normal, a specific normal. And yeah, then we want to make it such that our points needs to be a certain distance to the edge here. So we're gonna add some logic here, and we're gonna add some, you know what? We're only gonna add logic here. That makes it easier. So one is we're gonna assign this or not. We're gonna have to make these, we're gonna have to make this one and this one into lists or dynamic lists. But so if we want to constrain it to normal, then we just add an if statement here actually, before this. If normal is acceptable by the constraint, enter it. And for the second part, we just make this, we just scale this triangle pretty much. That's pretty good. Right, that makes sense. But then I'm wondering, we're probably gonna have two methods like this then. So one that has constraints and one that doesn't have any. Or like, I don't even know how. I don't know exactly what type of constraints I want and how I want to add them. So once again, let's take a look at this stone. One constraint might be one constraint is 100% gonna be, we just want to generate the eyes on one face. And when I say one face, I mean like either within this area or within this one or this one. And the easiest way to do that, I guess, is by normal. But then again, so that's really not a constraint related to the face we want to spawn things on. That's a constraint related to normals, right? I don't know, if we imagine that this mesh looked a whole lot of different, or maybe we can just, let's just assume the mesh looked like this. So this is one mesh. Then we actually have two faces with the same normal. And it's not like we only want to spawn things on this area and not this one, but rather, or let me put it this way, that's the difference between the two. In one solution, the normal, if we constrain by normal, then it would be able to spawn stuff on this one and this one, but then maybe later on we want the possibility to constrain by specific face, and then we would only be able, or we would only spawn eyes here or here. But I think we're going to start with the normal initially. And once again, it's here we're going to constrain it, right? So I'm thinking initially we could do, like, we split this method. So this is its own method. This is the one without constraints. Then we implement one with one constraint and then another with another constraint. Fuck, I don't know. Or we do some fancy interface sort of stuff. We implement like I don't know, distribution constraint. Where we send in a triangle. Like, we're gonna have, yeah, eventually it's gonna become quite an intricate system, I guess, of random distributions and systems. Random distribution, get random point on mesh. I think we are gonna do, fuck. What let's see here. If we do, yeah, let's just, actually, do I want to try this one first? What do we have? We send in a mesh and a transform, and that's about it. Yeah, let's try with this one. So we have something called, let's see what kind of result we get with this one. Visual property module position. We define a shapes, randomize shape every time. Visual property module position. Yo, what's up, Love? It's going pretty good. We're working on, I guess we're laying the first bricks of the like procedural system of the creatures, you know, like randomize some visual properties of the creatures, make them unique, but still cute. And it's complicated. Like, do I want to replace this one shape? Position module. Love, I can imagine. Is it a bit like when you add a beak or ears to creatures in Sonic Adventure 2? It's gonna be very similar, but hopefully we're gonna like put it or bring it up a few levels. The initial thing we have now, we have a very basic creature here, which just looks like a stone, and like we're doing the first level of this when we want to generate eyes to this stone, and then we want to generate like randomize some properties concerning those eyes eventually. So that's very much like the Sonic Adventure 2 example, but it's not as easy as, let's see here. Yeah, now we have a couple of eyes, but we have a very simple system so far where we just choose a random side of this stone, and that's where we spawn the eyes. And you can see here we still have intersections and stuff like that. So for instance, right now we define 6 shapes, 6 rectangles on this stone, and we spawn the eyes within those. That's pretty much it. But now we're trying to extend that system so that we don't define rectangles or shapes, but we use the mesh, and then we randomize points on that mesh given a set of constraints, and that's where we spawn the eyes. And then we're going to add the constraint that we don't spawn eyes inside of each other. And yeah, and we want to define this system in such a way that we can scale it later on, so it's not only stone meshes and eyes, but it's actually I don't know, a rounded head and horns or something else entirely. We'll see. We will see what happens. Yo, what's up, Bluepin Studio? Hope you had a wonderful stream, man, and thank you for the raid, appreciate it. Love, okay, I understand, thanks for explaining, no problem at all. I'm gonna be honest with you, when I'm explaining, I'm also explaining to myself. And as for new viewers, we're trying to implement, or we're winging it, we're freestyling a little bit over on this stream. We're trying to implement like a system for randomizing visual properties for our creature entities in this game. Currently, it's just randomizing a set of eyes on specific faces of this stone model, but it's gonna be a bit more complicated eventually, I hope. Bluepin Studio, creature collecting game like Pokemon. I guess all creature collecting games are always going to be compared to Pokemon. But think, like, instead of going out in the world and fetching creatures, you instead just run around in your garden and try to attract creatures. So it's more like Chow Garden, or Chow Garden in Sonic, or Viva Pinata, the rare game released in 2006, 5, 4. Yeah. Blueprint Studio, I love the Chow Garden in Sonic. Fucking me too, man. I spent way too much time in Chow Garden. Twitchbot, pick 2 random points on a sphere. Draw a ray from the origin to the points. Extend the ray until it hits the outer surface. So is this a solution to get a random point on this mesh, or what are we talking about? Isn't the solution of just getting all of the triangles of the mesh and just get the random triangle and then get a random point on that triangle? If you can figure out where the ray trace hits the outer mesh. So it's pretty much gonna result in... It won't work with like concave meshes, or is it convex meshes? I mean, it's a solution, but it comes with its pros and cons. It's probably a little bit quicker than this, maybe. I mean, doing the collision between a ray and a mesh is pretty much, it's not for free, you know? But basically what we do with this solution, which I like, is that we take all the triangles of the mesh and we also build up, like we accumulate the area and use that when we pick the random triangle. So it's weighted by triangle area. So we randomize triangle, weighted by area, and then we randomize a point on that triangle. I think it's a pretty straightforward, nice way to do it. Now I just want to use this method. I want to try it. And the problem is that our visual property module position, which is a module that decides the position of the attribute we're spawning. This one is tied to shapes currently. We're gonna improve it a bit. Or we're gonna remove the... We are gonna remove the... What is it called? I want to remove this and instead go with mesh. But now I'm thinking maybe we should have a visual property module position shape, or shape based position, and then we have a visual property module mesh based position. That is probably what we want to do. Yeah, let's organize it a bit. And yo, what's up, GDs? We're finally working on creatures. Hell yeah, we are. Look at them. Extremely like creative. Fuck, I'm getting... I think I'm starting to get sick. I have some cold going on. But let's see here. Modules, and then we do position. Because maybe we want to have multiple modules that random, or that decides our position. Property modules. Do I want to rename this one? Position by shape module. Hopefully I didn't screw up our current Sten definition. No. Or? Hmm. Hmm. This is empty. Yeah, I fucked it up. Fuck it. Oh, are we gonna have to clear this one, or can I just do this? Refresh. Oh well. So let's add. The problem with visual property module position by mesh is gonna be when we apply it, we're gonna have to send in more information. We're gonna have to send in the mesh itself. Or actually, never mind. Oh, I don't know. I want to send this. Okay, never mind. I don't think we do. Let's see here. Let's create it and see where we end up. Module position by shape. Module position by mesh. We're going to change this one to randomize shape every time. I don't think we can work with that one anymore. Debug, we don't really need a debug here. I don't think. Maybe we do. We'll see. Oops. I guess let's just try and do something like this then. Apply shape, get random point. Okay, let's do point, random point, or let's just do point is equal to and we'll take mesh, and the transform in question is going to be visual object transform dot parent. So then we have a point. Shape. Or here we just do local position is equal to point dot position. Although I wonder, local position, maybe we just wanna remove this one. We'll see. We'll try without it first. So now we have a position by mesh module, which given a mesh gets a random point on that mesh weighted by triangle area. Actually, it gets a random point on the mesh. And then we set the local position to be equal to that point position. Simple. Let's try it. The hard part is going to be to add some sort of constraint here, but we'll get to that soon enough. So let's add a module. We're going to bring it up. I want to do position first, and we do position by mesh module, and then we choose the mesh, and we're going to choose creature sten base model. I guess this is gonna suck. We're gonna have to get this mesh. Like, it would be nice if we could send it into the module instead, because I'm thinking of, I don't know how I'm gonna solve it yet. I don't know how much, I don't know where in the spectra between fully modeled and fully procedural I want to land, but like, we might have like X number of models for this creature, and then we randomize which mesh when we spawn one. Or I might try to do some shader solution where our stone mesh is just a sphere initially, and then we add X number of planes and cut it in real time then, I guess. Or when we spawn it. Fuck, wouldn't that be cool? The more I think about it, the longer our spawn, like the number of calculations that are going to be done when we instantiate a new creature in the world. We're going to have to do it multi-threaded, I think. But fuck, it would be so cool. But okay, let's try this one, see what we have. Did I set the definition? Yeah, let's try it. So the idea now is that we should be getting eyes anywhere on this mesh. I thought we get some errors instead. That's how it goes. Oh, it's not readable. Okay. Yeah, let's change that one then. But I wonder, what's the pros and cons? Okay, we're gonna rotate it as well based on the... Or do we do it? No, we don't. We're gonna rotate it based on the point we instantiate as well. Like, this might actually be the better way to do it. If we get the correct rotation on these and we don't place them so they hang outside, this might be a very cool way to do it. And then I guess if we get a stone creature with... Do I have a better example? If we get a stone creature with... that gets spawned with eyes like this, for instance, then that is super rare. Super rare and cute. But we probably want to weight our algorithm in such a way that we often get eye spawns like this. Or I don't know. Is it weird to have a creature like this? Once again, depends on how random we want to get with these. This looks so much better though, doesn't it? I don't know. Maybe actually. What the fuck? That's pretty cool. Yo, what's up? Simonidali. Sorry about the pronunciation. I did my best. We're trying to randomize some visual properties for our creatures. So in this case, or more specifically, spawn some eyes on this mesh. But we want to do it with some constraints, you know, we don't want it to look too weird. Yo, what's up, All Nate? I'm doing good, How about you? Same, cool. Yeah, I think so. We're also we're building the foundation of a very intricate sigil generation system for creatures as well, but we're kind of winging it. Yo, what's up, Clark King? Let's just go a little bit more crazy here and do 5 and 10 eyes, or actually just 1 and 10 eyes. So when it comes to constraints, we're gonna fix the rotation, and that one will be extremely easy. Then we're gonna have to fix this, spawning them on top of each other. That is gonna be a little bit harder. And then we want to fix this, I guess. We don't want to spawn them on the face edges if it doesn't fit, right? All Nate, great to hear you are good. I almost died last night. The fame was due yesterday. Oh yeah. Almost died. What the fuck, man? So how did the game assignment go? And did you almost die because you tried to do an all-nighter? I don't think any assignment ever is worth dying over. I don't think, at least. Okay, so I want to get the rotation correct. So with the previous solution, we had something like this. Take a look at this. We had a rotation module here, which we rotate relative to object origin, and we do it, and we truncate the rotation to be 90 degrees. So we only allow for rotations of the object that is in 90 degrees increments based on the relationship of the spawn point and the origin of the creature. Does that make sense? So now I'm just going to remove this one. Position by mesh module, and what we're going to do here is we're going to make our module system a little bit dirty already, because we're gonna introduce rotation in a module that is position. So yeah, so what I want to add here is rotate to rotate based on mesh face. So then we have a point here, and then we just do, finally we do if rotate based on mesh face, and we set, so we basically have a point normal here. So we have the normal of the face, and we want to make our object, we might want to decide, so in this case we want to make the forward vector be rotated or aligned with the normal, but maybe it's not always going to be the forward vector, so we're going to have to add some variation here as well, or some settings here as well. All Nate, bro, I worked so hard to fix bugs and add a lot of things, but when it came to time to merge everything broke, and it was almost as if I did nothing. It sucked like hell. I'm sorry to hear, and you don't know how relatable that is. Fuck, been there, and it sucks all around. But it usually works out in the end anyway, I promise you. So what I want to do here is visual object dot rotation transform dot rotation dot rotate set look rotation. Fuck, I always forget. We have done this multiple times. Which is the better solution? The better solution is the one in place. Interactable, placeable, and we do. What do we do? What do we do? Rotate to true. Place rotation. Place and get place rotation. Default. We do from to rotation. Hell yeah. So we do visual object transform rotation is equal to quaternion from to rotation. We want to go from visual object transform forward to point normal. I think. We'll see. We'll see. Running backend. So rotate based something. That looks good. Oh, I'm a little bit worried about... No, it looks good, doesn't it? It's outside though, that sucks. I would like to see... Looks good. Oh, fucking hell, this looks good as well, doesn't it? Yeah. So now we have rotation based on the faces. That's beautiful. That is beautiful. This actually looks... Fucking hell, this looks better. Harukanen is the back end running. You better catch it then. I'm gonna let it run free for a couple of hours. Hopefully it will behave a little bit better when it gets back. I think this looks pretty... When it comes to rotation and position, this looks pretty good. This is way better than the... I like this randomization way better than... way better than the other solution with the planes. And look at this. Yeah, sure, we have a couple of extra eyes, but this actually looks like a face. This one looks pretty good. Oh, this one, even cuter. If I got this one... Okay, these look pretty damn good, actually. The more eyes we spawn, the better as well. Okay, we have a few things left to do, though. Definitely. Fuck, I just remembered one thing. We can't... So my solution... So when we have a triangle... Fuck. This sucks. If we have a triangle, and so we want to make sure that we don't spawn an object. So if we get this point, we want to make sure that the object don't extrude over the triangle. So my simple solution was to just scale the points making up the triangle inwards, right? So instead we get this triangle, and then worst case scenario we get something like this. And that works, that's nice logic. But our faces, so if we have a face like this, it's gonna look like this possibly. Which means, so this is a triangle, and we want to be able to spawn things here, because this is still one face, one polygon. N-gon, I mean. So we pretty much want to... Okay, I would like this random spawn to be by N-gon and not by triangle. And N-gon would be per... where neighboring N-gons share normals. So this is already a little bit more complicated. So this eye, we don't want to be able to spawn it here, but if we scale this triangle, we wouldn't be able to spawn it at all inside of this triangle. But we want to spawn it somewhere inside this N-gon here, so it should be possible to spawn it here. Right? That makes sense. Okay. All Nate, I hope it does turn out well in the end. Thank you for the words. They're really comforting. Most of the time it does. I'm rooting for you. How to kind of free range backends, good stuff, make them taste better. My theory is that it makes them work better, at least, but I don't know if it's true. Okay, so this works so well. So I guess we could go through the mesh and reconstruct. Instead of constructing triangles, we construct n-gons. Binormal. Holy fuck, that is gonna be costly, I think. Yeah, I'm gonna have to think about this a tiny bit. So I'm gonna run AFK, make myself a cup of coffee, and when I get back, hopefully I have a plan of attack. So I'll be right back. Okay, back. But I don't have the solution yet. Let's see how complicated this would be if we do. I just want to see what kind of solution we would get if we do get random point on mesh weighted by n-gon. Area. Is that how you spell it? Feels weird. Get random point on mesh weighted by n-gon area in C# Unity. Not just triangles, yeah. 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 Polygons, yeah. Doesn't work that way. We wanna transform from our triangle-based mesh. We want to transform it into n-gons. I want these. But then we also, even though, okay, so let's say that we manage to reduce all triangles into x n-gons for this model or for any model. Then when we want to do a random point within this, so then we're gonna have to do a get random point within surface defined by y points, and then that surface might also be convex / concave. So yeah, that's also very, it's gonna need a lot of computation, but I'm not entirely sure there exists a better way, honestly. If we want to avoid this weird overlap. Or, depends on what information we have. Ooh. I'm wondering if we have... it's going to take a lot of calculations as well. Neighboring triangles, or check the... we get, I want to see mesh unity. Don't want to do a solution where we have to draw custom data in Blender. No. I'm pretty sure the best solution is to calculate or transform it to n-gons based on shared vertices and normal. How to reduce a mesh in Unity from triangles to n-gons based on shared vertices and normal. Let's see. Yes. Effectively doing polygon reconstruction or face merging from a triangulated mesh. Yes. Unfortunately, yes. Unity's internal mesh format stores only triangles. So if you want to reduce the yes, topology, yeah, exactly, yep. Build mesh adjacent. How long is this, by the way? So, okay, struct edge. So now we have shape, point, edge, triangle. It's weird that we have to define them ourselves, but whatever. Get hash code equals. Okay. Blood fill. Harukanan, do you know about our Lord and Savior, the Half-Edge? No, I don't. But okay, this is pretty straightforward. I like it. Let's see. And Allnate, as a beginner game developer, and I always wonder if using ChatGPT is ethical. What do you think? I find it quite helpful when I'm stuck, but I try not to rely on it. So what we're doing now, it feels like it's just a nice summarize. Instead of Googling and cross-referencing, it's just a nice summary. But it's definitely like it's probably trained on stuff where the original author might not have given it permission to use it. For stuff like this, I haven't really thought about it from an ethical standpoint, but for generative stuff, I still don't really think it's that ethical, honestly, because I have no idea what it's trained on. Harukanan, I recommend you to look it up. It is a very good thing when dealing with meshes. Half-Edge. Let's take a quick look. What is a half-edge? Oh, yeah. Yes. Yeah, I'm a little bit worried about this. Okay. Are we gonna develop our own modeling software within Unity here? Just because I want to get a little bit of a nicer procedural generation on my creatures. Allnate, I definitely despise AI for generative stuff, especially as an artist. I just feel like it's taking away people's creativity. Yeah, it's gonna be some interesting times ahead. I guess I'm just tired of slop, you know? And also, like what data it has been trained on. If you have your internal AI solutions and you train it on your internal data that you initially made, and then you make it generate stuff, then that's fucking great, man. So for instance, I would think about, like, I hate adding voiceovers to my devlog and shorts. If I could just take, if I could have a generative model and train it on my voiceovers so far and have a good result, and then use that instead of having to record everything, then like that's a fine use case for me. Same. Why it does have to be a mesh? What about texturing in shader? What are we talking about now? Are we talking about the eyes, or and what about texturing? Texturing what? All Nate, but with this I do feel it makes it easier to find ideas. You do not have to run around the web and documentation to know what might work. Yes, indeed. 100%. Sime, I meant eyes. Yeah, we're gonna have, for this stone creature, we're gonna have eyes as separate objects like this, because we want to have this 3D gem effect. But for other creatures, some creatures might have textured eyes, and so on and so on. It's gonna vary by creature. But in this case, we're working on Clark King. You can run a Llama or Gwen with a 360 12GB, maybe with 8GB, it could work. Oh, you mean with the voiceover? Yeah, unfortunately, like the results so far, I'm probably gonna need, I've got some live streams of data now, but like the result I've seen so far is good for generative voiceovers based on specific voices. But I would, sometimes it cracks. It's like soon it would be good enough, I think, for me to generate it locally. But what I'm getting at is like these type of generative solutions we see, like big studios have used similar stuff for a long while, I reckon. For instance, generating animations from mocaps and stuff like that. So my two biggest, like what I hate with generative AI the most, the two biggest faults or whatever, is like, what data is it trained on? Did they actually have the license to use that data? And B, it allows for so much slop. But whatever, let's see. This solution here, I would love to not have to go this far to get what I want, but I think this is our only. So just to reiterate, I don't want things to be able to spawn like this, so we're gonna have to limit them, and we're gonna have to limit them by these edges where we have one normal on one side and another normal on the other side. And to do that, Like if we have had access to half edge data in this case, wouldn't that work? Couldn't we get some information? Or am I understanding it? Allnate, I still believe it won't be able to replace what humans can do. Humans are so complex to the point where I do not think a machine will ever be able to replicate it. Yeah, I don't know, man. I wish that it was true, but honestly, I don't think it is. Harukanen, with half edge, you would just step around the face, no matter how many vertices. Let's see here. And what is half edge in a mesh context? Allnate, I guess we will have to wait and find out, huh? Probably. Will probably not be around when they when machine complexity goes beyond human complexity. But we will see. Yeah, to navigate polygonal meshes, especially those made of manifold surfaces. Like, I'm wondering if that's basically what we're doing here. But yeah, mesh processing. Every edge in the mesh is represented by two half edges pointing in opposite directions. Each half edge knows its twin, its next half edge, the next edge face around the same face, but a face here, that's just a rectangle, right? 4 vertices. Right? Or can is a face here an n-gon? Okay, I get it. That's beautiful. This is exactly what we want, right? But we would need to create this data structure ourselves. Because we don't store anything like this in, or Unity doesn't store anything like this. I reckon. That's just a guess, though. depending on how much shit we want to do. But isn't this pretty much what we're doing here? Ask that thing if you can convert Unity mesh representation to half-edge structure. We definitely can. I'm wondering, like, how different from what we're doing here is it? How would one convert a triangle mesh in Unity into the same mesh represented by a half-edge data structure in C#? Yo, what's up? Over on YouTube. I don't know how to pronounce that, but hope you're having a wonderful Tuesday so far. But for example, triangle 0, 1, 2, 2, 1, 3 means two faces. Holy shit. It's pretty short. How can we are in the weeds now, boys? Yeah, we are. Why do I always end up here? Let me the fuck out. In this, it feels like... Okay, so we just go through the vertices and we change them to half-edge vertices. Then we create a list of half-edge edges and half-edge faces. We get the triangles, and then we create a dictionary where we do int pairs and half-edge edge map. Okay. And then we go through all the triangles. We create a new face and 3 half edges. But come on, man, like what we do here is every face is just a triangle in this solution, isn't it? But I'm not going to be too quick to judge, because here we just create a triangle of half edges. Assign the vertices. Yo, what's up, Diligence? You use ChatGPT finally. I've been using it for quite a while, honestly. just not for everything, you know. It could have done an n-gon. Yeah, so here it does it. Yeah, okay, so this is... Yeah, we want to do edge collapse. Diligence, sometimes it has good suggestions. Definitely, 100%. No complaints today so far. Autocannon, it just created the entire thing for you. I don't know just yet. I don't want to celebrate just yet. I'm wondering if we are... you will need to convert it back into a Unity mesh as well, but that is fast and easy. Like, for our purpose, we don't really care about converting it back. We just want to convert it... We just want to convert it to this type for some... like, we want to calculate spawn points and things like that based on this. So we don't need to convert it back. Over on YouTube, I think it can produce so many draw calls to GPU. Not entirely sure. I know what you mean. Diligence, are you optimizing or problem solving? We're problem solving. Like, basically what we want is we want to spawn stuff on a random face on a model. So we need to calculate the faces. The current solution is to spawn things on random triangles. But we want to spawn things on random faces. So for this, these triangles making up this face, we just want to merge them into one polygon structure. So pretty much just a list of vertices going in counterclockwise or clockwise. And then we want to find a random point within that. But to be able to do that, we need to represent this by faces instead of triangles, where a face is an n-gon. Not entirely sure. Fuck, am I understanding this correct with twins? I don't know. Is this one collapsing it the correct way? Maybe we can check this one and test it. Diligence, can't you just pre-place them? What do you mean pre-place them? It would make just one triangle if you merge it to triangle. Like, when we convert this mesh, we're not going to draw it, we're not going to render it or anything like that. We want to convert this mesh into a geometrical data structure, which we can then use in like calculations on the CPU. We just want to get, like, I don't want to render it, I want to use it to calculate positions. So given this stone here, let me quit this. So given this one, it consists of X triangles and it consists of Y faces where Y is less than X, right? Because for instance, for this face here, you have 1, 2, 3, 4, 5, 6 triangles. We want to take this data structure, which currently represents this as vertices and triangles, and we want to represent it as faces, vertices and faces. So we want to simplify each face. Instead of representing it as a set of triangles, we want to represent it as like just one face, a list of vertices. Because if we have this one as a, what should I call it, a polygon line, then we can spawn the eye anywhere within it, and we can offset the eye we're spawning from the edge of it, so that we never get eyes that are hanging outside of the edge. Diligence, use normal from face. But what would happen in a case where we have multiple different faces with the same normal, but they are not connected? So what if our model looked like this? So just think of this as one model. Now we have this face here and this face here. They have the same normal, but they are not connected. So basically, I think I can draw this one pretty nicely. So maybe we want to do something like this. Let's say that we have, let's say that we have this mesh. If we want to spawn eyes here and we don't want it to go over the edges, my initial idea was to just minimize the triangles or scale the triangles, but what we end up with then is something like this. Okay, so now we can only spawn eyes within here, which means that we lose all of this area pretty much. Instead, what I would like to do is we take this one, we simplify it to a face if possible, so we get something like this, and then when we scale the area that we can spawn eyes on, we get something like this. Beautiful, right? So you want to split the rocks into multiple polygon faces, am I right? Yeah, so it's this. We want to collapse faces. Yeah, we want to collapse triangles, or we want to collapse edges in such a way that we go from having faces represented by multiple triangles to just being one face. Diligence normal from face plus connectivity points different groups. Yep, that's what we're doing. How to can and go through every half edge and compare to twins half edge faces out dot product 0 with its own face. All Nate, Robin, my good sir. I'm gonna get lunch. I hope you have a good rest of your stream. It's always nice to chill and see you make your game. Thank you, Nate. I hope you have a wonderful rest of the day as well. And enjoy that lunch. Just pre-calculate them into texture. Just pre-calculate them into texture. Maybe. I don't know. Haruganen, or is it 1 for dot product when parallel? It's 0. So dot product, if it's perpendicular, it's 1. Or no, if it's orthogonal, it's 0. And -1 if they are inverted parallel, right? So yes. All Nate, oh yeah, for sure I will enjoy it because my life depends on it. Yeah, that's a nice outlook. Nah, I think honestly, like, this is a very simple example. It can be extremely complex eventually, but I don't think there's anything wrong with this. And yeah, it's gonna take some computational time and stuff like that, but that's okay. We're just gonna do this when we spawn a new creature, and we're not gonna do it often, and we can offload it to a second thread, I think. So once again, we want to place an eye on this face, but we don't want to place it in such a way that it hangs out from the face. But I want to try this solution we have here. But I don't know. Nah, I don't think that this is what we want to do at all. Actually. Yeah, no. I think we're gonna go with this solution. I have more. But I'm gonna keep this in mind. Depends on how complicated we want to go eventually. Let's see here. Or get a point, get triangle that has same edge, adjacent 3 triangles. If I cannot placeable, move barycentric chord to center by a small amount. Yeah, but if you do that, like, The problem with that approach is that then you wouldn't be able to spawn any eyes on this triangle, right? Like if you scale by barycentric coordinates, you're tied to triangles, and sometimes you will have very thin triangles like this, and that's why we want to collapse it into one polygon instead. If I'm understanding you correctly. Then check for next triangle. Okay, so I'm just trying to follow here. So what you say is we randomize a triangle, we get this triangle, we try to place the eye here, we can't fit it. So then we should search for the neighboring triangle like this one. So we're going to go through the full data structure and find vertices that are shared between this triangle and this triangle. I'm just wondering in what way that would be a better solution than just converting, go through the mesh and convert triangles into polygons and then just randomize or get a random point. What the fuck? Yo, what's up, Retro Lizard? Why are you not using Claude? I have no idea. Why should I use Claude? Okay, beautiful. We're gonna try this one. I'm just not... Yeah, we're gonna try... Oh, and then we can... Yeah. Okay, let's see here. So I want to create a module Retro Lizard better in every aspect when it comes to code from compared to ChatGPT. I'm gonna have to compare it then. Or I'm gonna take your word for it and jump over to Claude next time. So we're gonna do a module position by, I want to do a module position by mesh, or position by mesh module, but get random point on mesh, random distribution. Okay, so we're gonna do something very similar to this. Or we're gonna add a additional method here, one that first transforms it into polygons before we get a random point. I think. But fuck, that's... How many calculations are we gonna have to go through? It's pretty costly, I think. Fuck, we just want to do this once. Not every time we're gonna spawn an eye. We can do it every time initially. But then I'm wondering if we have position by mesh. So as soon as we change this mesh, or as soon as we try to apply it the first time, that's when we recalculate the mesh and its properties to something we can actually use. Okay, let's see. We're gonna have to define edge. Okay, I'm thinking about, yeah, let's do it like this. Fuck, I hate the eye here. We're gonna add a line shape as well as, I think we're gonna add a polygon as well. And then we're gonna make point into a shape, I think. And we're gonna wait with point. But okay, instead of line, we can probably do edge. Hmm. I'm gonna call it line because I'm gonna want these to be infinite, or we're gonna have the option to have them as infinite. And then I think we're also gonna have, let's duplicate it again. Origin, direction. Defining it as 2 points, simple. Maybe we can just define it as a vector, but then we're gonna have to have, let's go with edge. Yeah, we're probably just gonna make shape into an abstract class because this one can be simplified like this for all of them, I think. Get random point, return math, lerp, AB. So that's our line or edge. Get bound. This one is gonna be the last thing we do. And I reckon this one is going to be quite complicated to implement as well, but we'll get to it eventually. So now we have edge. So the idea is that, yeah, this is our edge. We have triangles we want to return. So here we have a list. Polygon groups. Yes. Oh, do we define edge as indices here? Okay. Fuck. Hmm. What do I want to do this? Yeah, let's define private struct edge within this one then. The GPT's version edge points to array of points. Your version should have vector 3 since it's not point to an array. Yeah, we're gonna get to it. We're gonna get to it. Just want to make sure that we can follow along from A to B. So we could extend this if needs be. Sorry, English isn't my native. Actually, I've had no problems understanding it. I don't think so. It's pretty good. But then again, English isn't my native either, so... but let's have this one here. We will just use it here for now. Just a random hash code. So we can do equals. And then we always go from... So v1 should always be smaller. Right. And those VS should be read-only. Which VS? Okay. Ngons. This is what we want to replace with our polygons. Okay, beautiful. So like this. What do we have? Okay, so we just create new edges, AB, BC, CA, and then we check if it contains, then we, okay, yes. Huge triangle normals, and here I would like, I wonder if we can use triangles. We're gonna do it without it first. Exactly the same calculations we did previously. Let's leave that one. And then we do flood fill coplane. If visited contains, continue. Blood fill here. It's a little bit vague. I'm not following entirely here. But we'll see. Polygon groups. Okay. And then we're going to want to reconstruct the n-gons. Yeah, we're going to do this in debug later on, or soon. I think. Yo, what's up, Oslath? What you're currently working on? We have started developing a like a system for randomly generating some visual properties for our monsters. It's going to be a very intricate, big system eventually, but right now it's just for randomly spawn a set of prefabs on a surface, pretty much. Hope that answers the question. I don't know if it did. But basically, like in this specific case, we just want to randomize a number of eyes on this this model here, but we want to do it based on a set of rules which we define. And one of those rules, to be able to properly follow one of those rules, we need to convert our mesh from triangle indices to polygon based, basically. So the surface is also part of prefab. What exactly do you mean by that? The rocks are prefabs. Yeah, currently they are. Currently they are. Currently they are prefabs. I'm thinking about making them procedurally. Oslath, so you're making procedurally generated monsters. Yeah, I haven't really decided yet how procedurally generated they are going to be. But we'll see. So I guess it's the n-gons we want to take. Poly n-gons, yes. Okay. So it's actually maybe here. First of all, I want to take this one. you to just bevel those rocks, delete small faces in Blender. What are you getting at? Like, when we're trying to solve this problem we're sitting with right here, I'm just not trying to solve it specifically for the current model we're working with. I'm trying to solve this problem for like other models as well. So yeah, currently we're just trying to make it work for use case A, but eventually we're going to use it for B, C, D, and so on as well. Oslath, lycka till bro. Thank you, appreciate it. You too, you too. And finally, we are gonna take this and return it. Okay, actually, let's do it like this. Get random points on mesh polygons. We're gonna call it this for now, but what I want to do is let's just create a quick test script. Distribution test. Okay, and then we try it on this one. Let's see what we have. Try. 1 sec. Just gonna pour myself a new cup of coffee and plug in my headset. Okay, back. So the idea now is that I should just be able to drag and drop this one on this one, and we should be able to see the simplified gizmo. But we'll see. Did I fuck up? Okay, so mesh is null. Ah, because we don't wake. Fuck. Yeah, let's just do it like this. Wonder how slow it is. I guess we'll find out. Are we still... okay. That sucks. Okay. Sort edge loops. We get a list. We do dictionary next map. We failed pretty early here, I'm pretty sure on. Let's see, loop, convert all. Create a dictionary. Int binds to int. Int as key and int as value. V1, and then we just enter, so the V1 in each edge is the key, and V2 is the value. And then we start at first edge V1. And that's our current, and then we add current, and then current is next map. The fuck? So what the fuck do we want to do? Current 2, but how? Okay. Shouldn't we be able to just put this one in here? Yes. But that doesn't really change anything. Mm, okay, let's keep it like this for now and try and make it work first. So here we just build up. We create edges, instantiate edges, bind them to triangles, and we calculate some triangle normals as well. We polygon groups and visited. This is the flood fill. Normal threshold. It's this one. We pretty much get a broken edge loop. I guess that's the reason why this doesn't work. The question is, why would we get that? Okay, I want to see what happens if we just do... let's just return polygon groups. Which should be list. Oh yeah, we need to... Let's just return... I thought... Simplify it like this. Let's just skip sorting them. But I want to do this out here. Now we should be able to name this one group, right? Do we have... Oh, I think we might. Probably not. Let's see. Gizmos.color. I don't think we have anything. But one sec. Now we should have it, I think. Hmm. Did I fuck up? Yeah, we never add anything to this one. Get the fuck out. Okay, we're gonna solve this tomorrow because I need to run now, unfortunately. But yeah, I think this is basically what we want to do. And so the idea is to simplify a mesh into a set of polygons, or each face into a polygon. So instead of having X triangles, we have Y polygons where Y is less than X. And then we can get random points from those polygons instead of the triangles, because then we can apply some constraints in a nicer way. Hopefully, or actually, I won't be back tomorrow. I will be back on Thursday, but hopefully we can manage to solve this on Thursday. So yeah, thank you so much for watching, everybody. Appreciate it, and have a great rest of the day. Peace.